So welcome guys. Hello, I'm Pratik Karse and we met yesterday and now today we are learning classification and types of bridges. So components of bridges, concept of economical span, afflux. So what is HFLN? Score depth, loads on bridges, IRC loads, specifications, failure of bridges. I hope you are well and we will continue our today's topics. So first is introduction of bridges. So what is bridges? Bridges are virtual structure built to span physical obstacles such as rivers, valley, or roads, enabling smooth transportation and connectivity. You understand? So, so next is historically early civilization like the Romans, pioneers bridges construction with adequate and stone arches showcasing remarkable engineering for their times. So, over century bridge design evolved significantly with the introduction of steel, concrete, and modern construction techniques. Today's bridges are critical infrastructure that support economical growth and social connectivity, carrying billions of vehicles and goods worldwide. In the US alone, an estimated $40 billion investment is required to repair ag- aging bridges, highlighting a significance of sustaining this infrastructure for future generations. So think about that. This is biggest estimated cost I think I heard. So we are going to next, and we are discussing about classification and types of bridges. So first is functional classification. Depend on their function. Bridges are classified in bridges serve various functions such as adequates for water, pedestrians, walkways, highways, and railways. Each tailor for specific traffic and load type. So second is structural classification. Next is classified as structure. In that it include key structure type include beam, arches, truss, suspension bridge, cable bridge, stage bridge, bridges, each with unique load distribution characteristic and engineering theory. For example, you also know about Howrah Bridge, located in Kolkata. That is the best example of structural type bridge. And let's discuss about examples. Beam, Rio, Nitirio Bridge, Brazil. Arch, Sydney Harbour Bridge, Australia. Truss Bridge, 5th of 4th Scotland, Suspension Bridge, Golden Gate Bridge, USA, and Cable, Stade Millau Viaduct, France. So this is the best example for types of bridges. So you can search on Google and let's show these bridges, how they made and read about these bridges. I'm not going to discuss in detail. So next is bridge components. Bridge components is superstructure. They are classified into mainly in three types: superstructure, substructure, bearing, and expansion joints. So in superstructure, it includes the deck, girder, trusses, arches, and cables that directly support traffic loads and transfer them to the substructure. Then substructure means below the plinth level. Below the plinth level, it includes compresses piers, abutments, and foundations such as piles and caisson responsible for transferring loads to the ground safely. And third one is bearing and expansion joints. So it include bearing allow control movement between superstructure and substructure. Expansion joint accommodate thermal expansion, preventing damage. You normally see the bearings are provided in the our local bridges also. So next one is economical span. So first is what is economical span? Economical span refers to a optimal length between support balancing, construction cost, material uses, and performance. Then second is influencing factor, cost of material, labor, billing difficulty, and foundation condition impacts man selection to minimize overall expenses. Third one is life cycle cost, design decision, consider initiation construction versus maintenance. Cost, for instance, the 15% 2023 material cost in span strategies. So talking about what is afflux, what is HFL, and what is core depth in bridges. So first is what is afflux in bridges? The rise of water level caused by river. Flow obstruction near bridges piers leading to increased flood risk and structural stresses. Are you understand? Okay. So second one is high flood level HFL. Determined through hydrology studies, HFL is crucial for designing bridges clearance to prevent flood damage and ensure safety. So third one is core depth. What is core depth? The erosion depth around bridges foundation causes by swift water flow calculated using method like Lassie formula to guide protective measures. Loads on bridges. So talking about main four loads on bridges. So first one is dead load, second one is live load, third one is other loads. It includes self-weight, etc., etc. And fourth one is environmental loads. First one is dead load. Permit static load include the bridge's own weight. Sorry, it include self-weight. Dead in uh, self-weight of we will be included in dead loads. Second one is live load. Temporary loads from vehicles, pedestrian, trains combined with dynamic impact load. So third one is other loads. It includes longitudinal forces due to braking and buoyant forces in waterlogged condition are also considered in design. So third one is environmental loads. Wind load, seismic activity, temperature variation, and snow. It includes in the bridges. So going to next. So talking about IRC load specifications. So first one is overview. What is IRC? The Indian Road Congress set standard for loads bridges must withstand, ensuring safety and durability in India and all. So load classes, IRC classes A represent the heaviest vehicle. Class A and B correspond to the lighter but frequent loads for highway and rural roads. Third one is load distribution and impact. Will load distribution factor and impact coefficient account for dynamic effect of moving vehicle enhancing design accuracy. Fourth one is safety factor. Material and load safety margins are included to unexpected load conditions. So next one is bridge design consideration. So what should be considered while designing the bridge? So first one is hydraulic and structural design. Ensure adequate waterway for flow and that the bridge support anticipated load, safety and stability. So you need to uh, you need to give the minimum uh, height to flow the water for bridges. So second is geotechnical and seismic design. Foundation stability. It depends on soil characteristics. Seismic design improve resiliences against earthquakes. Third one is aesthetic design. Incorporative visuals, harmony, and environmental integration to create landmark and minimize communities. Description. So what is why bridges are fail in India? So talking about failures of bridges in India, first is notable failure, recent incident like the Morbi 2022 and Mergerhead 2018 bridges collapse revealed serious structural and maintenance issue because they do not maintain the bridge and bridge will be fail. Bridge was fail. Sorry. So second is causes. Failure stem from poor design, construction flaws, inadequate upkeep, and material deterioration such as corrosion and fatigue. Score and maintenance. Foundation score during flood critically undetermined inspection, irrigants, and quality control are useless. So talking about grid maintenance and rehabilitation. Firstly, regular inspection, routine check using non-destructive testing, NDT test, such as methods such as ultrasonic and radiography identify hidden defect early. So second is rehabilitation techniques. Repair method include concrete patching and steel reinforcement while strengthening employees FRP composites and external pre-stressing. Preventive maintenance, so protective coatings and corrosion preventive service life, repair and enhance longevity. So that said, this is done for today. We will meet soon in next video. So thank you. Take care. Bye bye.